Sinema. Appears to be in pretty good cosmetic condition. I did notice there are home brew switch the adjustment procedure for the idle bias. We can continue with this repair. We'll see you again soon on Solid State Sinema. Hello and welcome back to Solid State Sinema, the sequel of the Hitachi IA-600 repair. To perform this repair, we are going to have to go to D-Lab's MRO repair station. There's specialized equipment there to perform the task. Then we'll come back. Okay, so following my shop rules, I decided it would be best for me to change out all those old electrolytic caps to ensure that they weren't causing the bias drift. So we are reconnected with the meter across the fuse holder on that channel. Let's see if we still have drift. Here we go, applying power to the amplifier, and there is our idle current. And yes, it is still drifting up. So it was not the capacitors. So many of you wrote in and said, Terry, you probably got a leaky driver transistor, so I do have a set of them. I'm going to go ahead and replace those and we'll retest. So gaining access to the PC board for maintenance is a dream. It simply plugs in on an edge card. Our drivers are transistor 04 and 05. I'll get those changed out and we'll retest her. So we'll start with T05, which is a 2SA5337A. I'm going to use solder wick to desolder these leads. The last thing that you want to do is to heat these leads and just try to pluck the transistor out, because more than likely you'll raise the foil. So take a little solder wick. Don't allow the heat to be on the board too long. Use a solder wick until you see the leads move. Then the transistor come right out. There, so if you watch, you'll see that all the leads are free to move. That's what we want. So let's pop that out and get the new one in. Alright, before you install your new driver transistor, make sure that it measures the same way as the old one did on your diode check. So this transistor is emitter, base, collector. I'll put these little leads on here so you can see. So I'm going to go base to emitter. There's my 0.6 volts. Here is base collector. Same thing. And this should measure like the old one did. If it's reversed, you're putting in the wrong transistor. So verify that base configuration is right before you solder it in. This is the solder that I recommend you use on the circuit boards. It's Kester Rosin Core 31,000ths. Okay? When you solder these leads in, you don't need a lot of heat and you don't want that iron on there for a long time. Just get in there, boom, 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 done. Here we go. Check our bias with the new drivers installed. You can see the numbers are lower than the other set by about 10 milliamps. She's still drifting up though. So I do not believe the problem's fixed. Looks like that current is just going to continue to climb. Okay, well that's pretty interesting. So we obviously either have another transistor that's bad or some other component. I guess I need to inspect the board further. Alright, so I got the bright idea to pull that driver board from Mr. Drifty side and put it into the side that was stable. If you watch the bias, it is climbing. So the problem is definitely on the driver board. So that will rule out that I put in a bad set of new finals. So that's a good thing. Alright, so I dug a little bit deeper on the driver board, buzzed out some resistors, I found these two 270 ohm resistors that were measuring 315 to 325 ohms. So I replaced those with some 275%. And now my current is holding steady, but I still believe that these driver transistors were leaking because the ramp rate of the current went down by half when I put those in. So I believe there's a few things that are out of tolerance causing this problem. But now I believe the Hitachi is going to be stable enough for a test demo. Okay, I've got both channels working on the Hitachi IA-600. Now we need to actually test and set the bias. Now, as you know, down in the other lab, we are measuring across the fuse holders. That's okay to verify the channels aren't pulling more current than the other, but that is what we were testing, was the entire channel. So I've came up with a technique for determining the proper idle current just through the finals. So due to the fact that we could not find a schematic or the procedure for adjusting idle current, I decided to take the circuit board layout from their service data and add the output transistors. Here is the incoming power to the card, and that was a fuse that we removed and we're measuring current through this line. Now if you look, that was powering up this entire card, not just the finals. So what we assumed to be the current was not the current just through these finals, it was the total package. So what I've elected to do for our idle current adjustment is to just test the finals. And the easy way to do that is to remove this white wire, which is the emitter feed, and put an amp meter in line. Let me scoot over here and show you that part of the diagram. Well, here's the procedure for adjusting idle current on the Hitachi IA-600 amplifier from solid state Sinema. Pretty easy procedure. First off, you're going to remove the white wire from terminal 6 on the circuit board. That white wire will feed into one side of your milliamp meter. The other wire takes off and goes right back to pin 6. Now you are just measuring the idle current through the finals and not the entire circuit board. You're going to measure the current direct on your meter and adjust VRO2 for 25 to 30 milliamps of idle current. It's just that simple. Okay, here is the Hitachi under test per that diagram that I just showed you. To make it easy, I tack soldered a lead onto pin 6. So you can see this is one side of my current meter and this is the other. So the milliamp meters are simply looped in on each of the channels. This is my repaired channel and this is monitoring the stock channel. You can see my currents are stable. The next step will be to hook some speakers up to it and hear the old Hitachi sing again. Alright, I have adjusted both channels to give us the proper bias current, so now we are in spec. I can hook the wires back up and we'll go down and hook up a CD player and listen to the Hitachi. Okay, it's test time of the Hitachi. I have a set of Polk audio speakers, a JVC CD player, and of course the Hitachi. At my past shops we called this smoke test time. After all, what could possibly go wrong?
Hello, Peter. What's happening?
Oh boy, it can't be DFI. That's Dick from the internet. I thought that you had been taken by Andorians and I'd never see you again. I see they have fitted you with some sensors on your head. What, do they get tired of your crap?
Yeah, no. They wanted to liven up your boring YouTube channel. I told them I was the real talent.
Well, I can't say it's good to see you again. As a matter of fact, I still have ways to get rid of you temporarily. You want to see it? Well, this works on flies. Let's see if it'll work on a troll. On a troll. Well, here we go. The moment you've been waiting for. What does a Hitachi sound like after repair? got it teamed up with my good old JVC CD player, and we're using non-copyright music so I don't get popped. So here's your balance. Both channels working. And the Hitachi sings again. So yes, my friends, Solid State Sinema is back, as well as DFI, but we'll deal with him. 2023 is the year I have decided to take on more of the Silver Series 70s classic receivers and amplifiers. I need to feed this if it's going to continue, and I also need to know if it's what you want from D-Lab Electronics.